Hey everyone, and welcome to today's lesson about reflections. To get us started, I've got a picture of a completed reflection right here on the top of the page. Figure or triangle BUG, triangle bug, has been reflected over this line, and I have B prime, U prime, G prime as my image. All right. Now, a couple things. When this triangle bug was reflected over the line, the orientation of the figure was reversed. Okay, and let's talk about what that means. If I look at the vertices and I read them BUG, I move clockwise around the triangle. Okay, if I still want to read in that order BUG, I need to move counterclockwise around the image. Okay, so the orientation is the direction in which you are reading the vertices. That direction gets flipped once the figure is reflected. All right, something else kind of special. If I were to take a segment connecting the pre-image and the image points, you would notice that the line of reflection is what's called the perpendicular bisector. Okay, this line of reflection intersects that segment at a 90-degree angle, and it also bisects the segment. And that's how we get the perpendicular bisector. So we'll get that down here, the perpendicular bisector. Little typo there, of a segment is the line that is perpendicular to the segment at its midpoint. Okay, so if you look at these segments, the line of reflection goes through the segment at its midpoint and also intersects at a 90-degree angle. Okay, let's keep rolling. I've got another picture of a completed reflection. Okay, so in this case, triangle ABC was reflected over line M, and we call line M the line of reflection. All right, line M is also the perpendicular bisector of B, B prime, and C, C prime. Okay, notice that point A lies on the line of reflection, so when I reflect A, I get A. Okay, A and A prime are the exact same point. Now, if a point B is not on line M, then M again is the perpendicular bisector. I'm having you write that down twice because it's really important. Perpendicular bisector, sorry for that sloppy writing there. In this case, if you look at B, B prime, the line of reflection is that perpendicular bisector intersects at a 90-degree angle and splits it in half. Okay, now a little bit about notation here. Okay, if we're going to do a reflection over line M, we're going to use a lowercase r for reflection. In this case, we're reflecting over line M, so M goes down in the subscript. Okay, the subscript will always be the line of reflection. And then just like a translation, I've got to indicate what figure I'm reflecting. So I am reflecting triangle ABC. The result is triangle A prime, B prime, C prime. Okay, let's do an example. Down below here, I've got triangle ABC, and I have listed the points there. That are the vertices. We want to find the reflection over the x-axis of this triangle. So I'm going to go ahead and just highlight the x-axis here. Kind of put a dash line there. That'll be my line of reflection. Okay. When I go to reflect these points, remember they are in the exact same position, just on the other side of the line. So point A is 4 units above the x-axis. It needs to go 4 units below the x-axis. So down here will be A prime. B is also 4 units above, so it'll go 4 units below. Here's B prime. And then C prime is 1 unit above. It needs to go 1 unit below. Okay, if I connect those points, I now got the same triangle, but now reflected over the x-axis. Okay, part B asks us to list the vertices of our new triangle. So A prime is at the point 2, -4. B prime is at the point 6, negative 4. And then C prime is at the point 3, negative 1. Now take just a moment, look at the original points, and then look at my image points. What do you notice? One thing that you might notice is that the points are identical except for having switched the sign of the y-coordinate. Okay, when I reflect over the x-axis, the sign of the y-coordinate is the only thing that changes. Pretty cool stuff. It's always important to be looking for patterns, even when we're doing geometry and reflections. Okay, so example 2, I'm going to assign a handful of these to you, and then there'll be a few that I do on my own. In each of these questions, we are reflecting the point 2,5. Okay, we're going to reflect the point 2,5. I'm going to go ahead and do part A. I'll also do C and D. Those are a little bit tricky. And then you'll be responsible for B and E. All right, let's go ahead and plot the point 2,5. So over 2 and up 5. Okay. If I'm going to reflect over the x-axis, and that's down here, right, x-axis, I need to move that same distance just on the other side now. So I'm 5 units above. I've got to go 5 units below, and I'll go ahead and do that in black. Okay, so that's now the new point 2, negative 5. Again, like I said, when we reflect over the x-axis, it's just that y-coordinate that changes. All right, next thing it says, we're going to reflect over the line y equals 2. Okay, remember the line y equals 2 is actually a horizontal line. It's right here at 2. If I'm going to reflect over that line, I just need to move the same distance away from that line. So the point is currently 1, 2, 3 units above. I need to move 1, 2, 3 units below. Okay, so that new point is 2, negative 1. Okay, again, notice that x-coordinate did not change. It's only been the y-coordinate so far that has made a change. Okay, now let's kick it up a notch. This one's a little bit more challenging. I'm going to reflect over the line y equals x. Remember the line y equals x is that line that's perfectly diagonal from the origin. Okay, it's got a slope of 1. Now, if I'm going to reflect over this line, I'm going to move the same distance down, and then I'm going to move that same distance to the right, and it'll end up being the same distance from the diagonal there. So I'm going to move down 1, 2, and I need to move that same distance now in the other direction. So my new point will actually be the point 4, and then what is this, 3 here? So over 4 up 3. Okay. And then you guys can try the next. Go ahead and pause the video and reflect those points. All right, we're back. So if you're going to reflect over the y-axis is right here, reflecting this blue point. I'm 2 units to the right, so you've got to move 2 units to the left. So your new point should be at negative 2, 5. Notice what changed there. I changed now the x-coordinate. Okay. Lastly, you had to reflect over the line x equals negative 1. X equals negative 1 is a vertical line that goes through negative 1. And the point is 1, 2, 3 units away from it, so I've got to go 3 units on the other side. 1, 2, 3. Looks like that has an ordered pair, negative 4, 5. All right, there you have it. I'd like to make one correction here. This was not a very accurately drawn line. Okay, so actually when I reflect over the line y equals x, I should have gone down 1, 2, 3. Okay, which means I need to go to the right 3. 1, 2, 3. And something pretty cool happens here. I apologize for not doing this earlier, but the x and the y coordinates actually flip. If you look at the new point, I went over 5 and up 2. Okay, over 5 and up 2. Those are the new coordinates there. All right, your next step is to complete the 8.2 Math Excel quiz. That's all for now.